Good morning, students. Today I will explain you gas laws. Gas laws means what is relationship of the temperature, pressure and volume. If out of three, temperature, pressure and volume, suppose your temperature changes, it will affect the pressure and volume, and if pressure changes, it will also affect the temperature and volume. So there are different laws. First law is Boyle's law. Boyle's law, in this case, when temperature is constant. Boyle's law, in this case, when temperature is constant, it is the pressure volume gas law. So when temperature is constant, volume of a given mass of a dry gas is inversely proportional to the pressure. That is, V is inversely proportional 1 upon P. Again listen, Boyle's law. In Boyle's law, relationship pressure and volume when temperature is constant. When temperature is constant, then volume of any gas is inversely proportional to the pressure. That is, V inversely proportional 1 upon P, or we say that V is equal to K upon P, where K is a constant, or V into P is a K constant. Now it means, listen, when temperature is constant, then volume and the pressure, that is product of the volume and pressure, is a constant value. Suppose at P1 pressure, volume of gas is V1, and then if V changes P to P2, then volume will also change. So product of the V1 P1 will equal to the product of the V2 P2, that is a constant. So the point is that in the case of the Boyle's law, when temperature is constant, volume is inversely proportional to the pressure, and V is equal to K upon P, where K is a constant. So product of the volume and pressure is a constant. Now second was the Charles law. Here, when pressure is constant, then relationship of volume and the temperature. Charles law, that is volume and the temperature relationship when P is constant. So volume of a given mass of a dry gas. Here, P is constant. Volume of a given mass of dry gas is directly proportional to the temperature. Or we say V is equal to K into T, that is K is a constant, or V upon T is a K constant. Now suppose at given temperature, volume of the gas is V1, and then we change the temperature T2, volume become V2, then we will say that V1 upon T1 is equal to V2 upon T2, that is a constant. Now this Charles law can be explained at constant pressure, volume of a given mass of a dry gas increases or decreases by 1 upon 273 of its volume. Again listen, at constant pressure, volume of a given mass of dry gas increases or decreases by 1 upon 273 of its volume for each 1 degree increase or decrease in the temperature. So the point is that decrease or increase in the volume is 1 upon 273 of its volume with an increase or decrease of 1 degree centigrade. This is known as Charles law. Now, if we add up Boyle's law and Charles law, see here. as per Boyle's law, V is directly proportional 1 upon P, and as per the Charles law, V is directly proportional to T, then we can say that V is directly proportional to T upon P, or V is equal to K constant T upon P, or it can be written in the form of V into P upon T, that is a constant. So, if at T1 temperature, P1 pressure volume is V1, then V1 upon T1 is equal to the, when the pressure changes to P2, temperature changes to T2, then volume becomes V2, it will be a constant value. So this is the gas equation. V1 P1 upon T1 is equal to V2 P2 upon T2, that is a constant. Now all these values of pressure and temperature, they must be taken in the standard temperature and the pressure. Now listen, what is absolute zero? It was found that at minus 273 degrees centigrade, volume of the gases are ceased to zero. So absolute zero, that is minus 273, and here we are taking the Kelvin as the standard temperature. If we increase minus 273 to 0, that will be equal to 273. So Kelvin is 273 plus C. Suppose we are doing this experiment at 20 degrees centigrade, then the Kelvin will be 273 plus 20. So all these values, they are always taken as standard temperature and the pressure. Okay, so this is the Boyle's and the Charles law, very simple, and this is the gas equation. If you like my videos, please share and subscribe. Okay, thanks very much.